All right, good evening, everyone. If everything's working correctly, you could see a screen says Rebuilding LINQ because the full title would be way too big for this. Let's go ahead and get started. So, a little bit about myself. My name is Cameron Presley. I am based out of Charlotte, North Carolina. I've been an engineer in some shape, form, flavor, or fashion for well over a decade now. Done everything from intern all the way up to in place director of software engineering for a bit. So, been there, done that, have the t shirt probably from a conference or so. I am a Microsoft MVP. All that means is that I do a whole bunch of stuff for the community and am not compensated for it in any shape, form, or fashion. So I became an MVP because when I started out software engineering, I didn't know anything. Right? Had my little comp sci degree, and I thought I knew everything I need to know because I was great at C++. Man, I got humbled fast, right? And what really helped me out was there was a lot of people who were blogging and speaking at conferences and writing books, and that really helped me kind of find my way, right? Getting that wisdom. Well, I made the decision to start doing the same thing to give back. And in fact, this year actually marks my 10th year of speaking at user groups and conferences. So yeah, that's kind of what all that's about. So if you ever want to talk about technology or geek out about things, totally hit me up. Something else a little bit about me is I do woodworking. I'm not great at it. Here's like the first project I ever built. It's a workbench. It's on wheels. The wheels aren't level, but the table itself is. Don't ask me how that works. I guess if you miscut the right number of times, it works out. I mention this because you're going to see some things tonight that are going to be new and or potentially strange to you, and it's going to make you feel uncomfortable. Lean into that, right? Lean into that uncomfortableness, try it out, think about these ideas. And I'm going to go ahead and warn you, your first time doing this, it's probably going to suck. That's okay. That's normal, right? If you were great at it on your first shot, then you're really not pushing yourself, are you? But enough about that. Let's get into it. Already mentioned this, but I'll do you one better. Let's say you can't make the talk or you really want these slides. Everything you're going to see tonight's already live. If you trust me, you can take a screenshot of the QR code. If you have recently passed your InfoSec exams, you're not going to scan the QR code. In fact, you're going to go to blog.softwarementor.com/presentations. You'll find this talk and more there. Momentary pause, and let's go. So here's what we're going to cover tonight. First thing we're going to talk about is what is LINQ itself. Even though LINQ has been around for quite a while, at least almost 15 years now at a minimum, I still find sometimes engineers don't understand exactly what it is and how it works. So we're going to talk about what is LINQ. We're going to talk about the three parts that actually make up LINQ, that if these concepts weren't in the language, LINQ wouldn't even work. And once we've talked about that, we're going to write our own version of LINQ, implementing something that I like to call the trinity, the three most common operators. So this is your select, your where, and your aggregate. And instead of just writing this from scratch, we're actually going to be deriving the LINQ methods from other production code. All right. Let's talk about LINQ. So here is some C# code where we have a delivery team and it's got some properties on it, right? It's got a name, it's got a team lead, and it's got some member count. Right? So far, hopefully nothing too terribly crazy. And we've got some teams like the following, right? We've got an alpha team that's led by Alice. It's got 5 team members on it. We've got Back to the Code, led by Bob. It's got 7 members on it. Then we've got another team called Skill Overflow Exception, led by me, with 10 people on the team. And then we've got Getting Things Done, led by Dana. So we've got some code here, and we want to answer some questions, right? So let's say that we want to write some code that would help us find teams that have more than 7 members on them. Okay. So we might write a function that looks a little bit like this called find too large of team names. And so we set up two large teams like result, if you will, of a list of strings. We iterate through the teams. If the member count's greater than 7, we add it to the list and we return that list. The question for you all, though, is what are the actual business rules? There's a lot of code here, but what are like the parts that we actually care about? If you didn't realize this is going to be some back and forth conversation. So if that makes you feel uncomfortable, that's okay. I'll talk enough for both of us. But it does help if people chime in either through the chat or verbally. All right, I'm going to assume that the pizza is tasty, and that's what's happening here. Yeah, there's only a little bit of business rules.
No, I just had to walk up
Oh, gotcha.
because I was sitting there comfortably with my Calpico.
Oh, no worries, no worries.
So we had one, what is it? Team dot member count is greater than 7.
Yeah. So team dot member count greater than 7 is one of the business rules. And then the other one, which is a little bit unclear, is actually team dot name, right? Because that's what we're trying to get. But we have all this other cruft in the way, right? Like we
Prasad's
had
in the same thing too.
yeah, exactly,
Mentioning.
exactly. So what if we could write our code in such a way that brings the business rules up front instead of having to parse through all this code? Well, here's how we would write in LINQ. We do teams.where member count greater than 7, get the name, return that as a list. Here's our business rules. Less code to parse. That's kind of helpful, right? And you'll see a little bit later that LINQ is really powerful because it also restricts the things that we can do, which means the odds of us breaking something drop dramatically. So it's kind of nice that we're able to write this. So LINQ, if you look up like the MS Docs definition of it, says it's a set of operations that work on data independent of its source. So it doesn't matter if it's coming from like a database, if it's coming from a file, if it's coming from in memory, if you've got a really cool machine that can read smoke signals, that doesn't matter either. It just works. And the reason why this is so powerful is that not only does it work independent of the source, it's actually type safe, which means if we do mess something up, your code's going to break at compile time. Now, I don't know about you, but if I'm going to ship a bug, I'd much rather catch that in my CI part of my pipeline and not when the user's running the application in production, right? So anything we can do to shift finding those errors sooner is going to make things easier and a lot more fun for us, honestly. The other reason why I like LINQ is, and I kind of alluded to this before, it's just less code, right? I don't have to read as much. I don't have to parse as much. I can get your intent a lot quicker. And I alluded to this a little bit earlier, but I want to talk a little bit more in detail. Principle of least power. So Tim Berners-Lee has this really great quote that says that the choice of language is a common design choice. The low power end of the scale is typically simpler to design, implement, and use, but the high power end of the scale has all the attraction of being an open-ended hook into which anything can be placed. So, like, you could write stuff in assembly, and you could do all sorts of stuff in assembly, but you could do all sorts of stuff in assembly, right? If we take that into this same concept, the idea is what type of code could we write inside the for loop? Right? What can you do inside a for loop? You can do anything, right? You can write any code you want inside this for each loop and it'll be perfectly happy. However, what can you write inside where and select? Well, funny enough, not terribly much, because where only accepts functions that, in this case, take in a team and return back a Boolean. There's only so many ways you can write that. And same thing with the select statement, right? It only lets me convert the team into something else. So if I want to do logging or database calls or stuff like that, I can kind of, but man, I've really got to force the code to do that. And guess what? It's going to look obviously wrong. It's going to get flagged in a PR review. It's going to get flagged in a code review. At least it should be getting flagged. So not only does LINQ help you express your intent of what you're trying to do, it also forces other engineers to follow your guardrails so they don't try to do dumb stuff in your code, which I don't know about you, but I appreciate. All right. So how does LINQ actually work? So LINQ needs three things: funcs, generics, and extension methods. If .NET did not have these concepts, we wouldn't have LINQ. It would not make sense. And in fact, if you were to look at what times and what years funcs, generics, and extension methods got introduced, it was right before LINQ got introduced. So you could almost think like, oh, hey, someone already had LINQ in mind. They were just building up, right? And this would be MADS. So in order to write our own version, we've really got to understand what these three concepts are. So that's what we're going to do next. We're going to start diving into these. And first, we're going to start with funcs, right? So funcs are a really interesting type in .NET because they don't represent a value, right? They're not like numbers or strings or even objects per se. They're something that you end up having to invoke. And when you invoke them, you get data to come back. So in this slide, we're going to look at a couple of func signatures and just make sure we can understand and how to read them. So for example, a func of int like this says that get number is going to be a function that takes in no parameters and returns an integer. So a possible implementation may look like the following, right? No matter how many times I call get number, I'm always going to get back 2. It's not going to do anything else. Another function where it's int comma bool, the way to read this is the last parameter is always the return type and everything before it is the input. So in this case, this is a function that takes in an integer, returns back a Boolean. Such a function could be called as even. And what we're going to do is we're just going to make sure that x mod by 2 is equal to 0. So far, not so bad. And we can keep taking on more and more inputs. I think that .NET allows you to define funcs with up to either 8 or 9 inputs. It's an insane number. And if you're writing functions like that, let's not, right? We're probably overcomplicating something. So for this example, we've got a function that takes in a string, returns a string. We can call it repeat, and it can do some other code here. I don't necessarily care that you read and understand this code, just as long as you understand the type signatures. As long as you got that, we're in a good enough spot. And if you're like, hey, Cameron, I don't think I've ever used funcs before, you probably have. If you've ever used LINQ, you've absolutely used funcs. In fact, it's the stuff that's inside the where and the select. That where clause, for example, is actually a function that says, give me a delivery team, I'll return you back a Boolean. And select is a function that says, if you give me a delivery team, I'm going to give you back a string. These are so much so that they're funcs that we can actually refactor this code and make it look a little bit different. For example, I can literally extract those functions into named variables, is team2large and get name, and then replace them inside the where and select. This code will still compile. I'll be happy to do so, right? We can go even further. Let's say you wanted to unit test this. We could actually move them to their own methods, and this would still work as well. Now, granted, there's some like compiler magic that's happening that will actually coerce a method into a func, but for all intents and purposes, it's the same thing here. So that's all we really need to know about funcs. So I'm about to go into generics, but before I do so, I'm just going to double check the chat and double check the room to see if there's any questions about funcs so far. Okay, counted a couple seconds there and have not heard anyone, so we'll keep going. Next up, generics, or this cup of tea, if you will, for my tea drinkers in the room. So generics are pretty easy to spot in .NET. Just look for the angle brackets. So if you've ever used the list type, you've absolutely used generics, right? So list event, list string, list delivery team. And with just the func stuff we looked at, it's also generics, right? With the delivery team and bool here inside the angle brackets. But why do we have generics? Something that I actually find really surprising is that generics were not in the first version of .NET. You pretty much had to always make your own copies of everything. So I always find that fascinating because I use generics all the time. But let's take a look at a real life example. Going back to Ori's joke earlier about data structures, let's say that you were tasked to write a queue structure and you couldn't use like any of the built-in .NET types. So you're like, all right, cool. You know what? I can make a number queue with integers and we can use a list to back it. That works great. You ship the feature. Everything's awesome. But then you get another requirement because this is how software development works, right? We always get new requirements. And now you need a way to be able to set up a queue for strings. So you go, all right, cool. I'm a pretty sharp developer. So I'm going to create a new queue called string queue, and I'm going to put its logic in. You do this, everything works, but your pattern matching brain looks at this and goes, huh, this is a bit odd. This code looks almost exactly the same, right? And in fact, if you were to dig a little bit deeper, really the only differences are the types. So this is kind of your clue, right? If you're ever defining a class or functions or whatever, and the implementation is pretty much always the same, the only thing that's different is the types, you can probably make it generic. So in this case, what we do is we create a new queue, and then I'm going to introduce a generic at the class level, say T. And what this says is that whatever type you pass in here, I'm going to use that everywhere that you see a T. So that's for the list of elements, that's for add, that's for pop, that's for everything. And once we do this, we can get rid of the number queue and string queue stuff we were working with and actually just set the type when we new up the queue. So that saves us a lot of code, makes our code a little bit more flexible. And guess what? We can now support other types. So if somebody comes around and says, hey, I need a queue of delivery teams, they don't have to rewrite the code. They can just reuse the existing queue. Pretty neat. Right? So that's it for generics, at least for the level that we need. So going to do the same thing again, just going to double check the room, see if there's any questions about generics and or the chat. And I like doing like a 5 count mentally on that. Okay, let's talk about extension methods. So let's say that we're in this code base and we're trying to review a report, and we get the requirement that we want the date in the form and the report to be a very particular format: 4-digit year, 2-digit month, 2-digit day. And we write the code to do that, right? We get now, and then we do now.toString. We pass in the format string. Hip hip hooray! Unit test pass. Everyone's super happy, except for the product owner. Man, it's really hard to make product owners happy consistently, because now what they say is like, "Hey, this looks awesome," but we're now inconsistent because now we have dates in some places that are year, month, day, and in other places we have it month, day, year. Can we be consistent? That seems like a reasonable request. So what we do is we need to figure out a consistent formatting for date. So we write some static class stack method called date formatter, and then we do format date for display. And we just put that logic in there, right? Date.toString, year, month, day. We update all the places. Things are kind of okay. But now our code kind of looks odd, right? Because now we're doing this date formatter dot format date for display. That's a little bit clunky. Not awful, but just a little bit clunky. Well, one thing we could do instead is that instead of writing the static class that we have to invoke, we can actually write an extension method. And what extension methods are is they allow you to attach functionality to a type without it actually being defined on the type itself. So here is our code from before, right? Date formatter, format date for display. To make this an extension method, all we've got to do is just add the this keyword in front of datetime.date. The minute we do that, because it was already a static class, already a static method, the minute we do that in our production code, instead of doing date formatter dot format date for display like the top, we can actually do the bottom. We can just say now dot format date for display. Pretty cool trick. It allows you to put your code in libraries that were shared. This is especially great if you're trying to tie functionality to objects that you don't own, like for example, strings and date times. And we'll see. Okay. The other thing I'll mention before we go talk about LINQ is if you're like, I don't really like extension methods, well, I'll let you on a little secret. If you've ever done any ASP.NET and anything with .NET, like 5, 6 up to now, use extension methods all the time. That's how startup works, right? When you do that services.add registration or add lifetime, right? And you specify like singleton versus per request per versus whatever, those are extension methods that are powering that. So you're kind of already using them. In fact, if you're using the built-in logger stuff for ASP.NET, that's also all extension methods all the way through. Like when you do log error, log warning, those are extensions that just do a prettier version of .log. And oh man, Ori's got a cool comment. And extensions will be first-class citizens in C# 12/.NET 10, or whatever the next version of C# is. Yep. I'm definitely excited for that. So if you saw funcs, you saw generics, and you've seen extension methods, you could have invented LINQ yourself. Extension methods are such a core part of LINQ that when you look at the Microsoft docs for extension methods, it literally has this quote: most common extension methods are the LINQ standard query operators that live on IEnumerable and IEnumerable of T. That is how critical extension methods were to make LINQ work. Because here's kind of the beauty of it. LINQ works on the IEnumerable type. So if you define any type of your own, as long as it implements the IEnumerable interface, you get LINQ for free. That's crazy powerful. But enough about the fundamentals. Let's go and start writing some code. And so the way this is going to work is we're going to look at some code and it's going to work, but it's going to look a little bit odd. And what we're going to do is we're going to refactor that production code into our own version of these LINQ methods. So we've got some restrictions. The first restriction is that we have to extend off the enumerable type. And the reason why we're going to do that is because that's what LINQ does. We're going to follow the same kind of code contract, if you will. It also has to have the same type signatures of LINQ. So so for example, the select method on LINQ, it always takes in a func and it takes in a single func. Well, our version of select will do the same thing. And then same thing for where and for aggregate. And then the last guideline we're going to follow is that it's going to have the same properties of LINQ. Now, a lot of people are familiar with the methods of LINQ, but they don't really think about what are some of the guarantees you get with the various methods. So we're going to explore that a little bit too. So let's talk about map. So map is when we convert from one type to another. And usually you're going from a collection of one type to a collection of another type using a mapper function. Now, in .NET LINQ, it's called select. I can go and tell you no other language calls it select. For the JavaScript, TypeScript people in the room, it's called map, and like every other language, it's called map. I have no clue why Microsoft chose select. My only guess is that it would help those coming from like a database background feel a little more comfortable, right? Because select is like a select query. But otherwise, almost every language calls it map, so that's what we're going to call it here. Now, you get some really cool properties with select and map. First of all, it maintains the length of the collection. So if you call select on an empty list, you get back an empty list, right? Not a list of 2 items, and you don't get back null. If you call select on a list of 5 items, well, you're going to get 5 items back. Not 4, not 6, not 0. So that's pretty cool. You're also guaranteed that the results are all of the same type, right? So if I am mapping a list of strings into integers, I'm going to get back a list of integers, not, well, some of them are integers, some of them are null, some of them are objects. Like that's not going to happen. The code won't even compile. And I've alluded to this before, but the collection you get back can't be null. So that's a lot of cool guarantees that you get. So let's start writing. Here's our delivery team code from before. And we've got a requirement from our product owner that says something to the tune of, hey, we've got these delivery teams. We want to be able to see the names. So you go, all right, cool. I can bang this out real fast. So we write the following code, right? We set up a list of names. We for each of the teams, add the name to the list of names. This is bog standard C# code that, you probably were able to write after your first couple weeks in the language at the most. So we get this. This works. It's great. The problem, though, is we start wanting to have this code in all sorts of places. And we don't want to just copy paste this code everywhere, right? We want to put this in a shared location. So what we're going to do is we're going to create a set of extension methods for delivery team called getTeamNames. And we're doing the exact same logic before. The only thing is I've just put into a static class, static list. This is super testable. I'm not worried about any like solid principal issues or anything like that because honestly, it's not going to come up here. So this works. Things are great. But as I alluded to before, it's really difficult to make product owners happy all the time. So you'll get a new requirement where now we want to see the name, all the team leads. And we go, all right, cool. We can do that. So we're going to short circuit a little bit and we're going to write another extension method called getTeamLeads, where we say var leads equal to new list of string. We iterate through the teams. We add the lead name to the leads and return. The code works. Everything's great. But then we start taking a look at these 2 extension methods and we go, man, these look real similar, don't they? If you ignore the method names and just look at the internals of each function, there's really only one difference besides some naming, right? And that's what we're adding to the list. That's the only difference between them. So what if we could figure out a way to change our code a little bit where we can make this a little more flexible? Now, given the setup, you might be thinking generics, but actually we can use a func. So here's what we're going to do. We're going to create a third extension method called getStringValue. This is a terrible named function, but just bear with me. We'll fix it in the not too distant future. So it still extends off the delivery teams list, but now we're going to take in this new input. It's a func that goes from delivery team to a string. And inside our for each loop, we're going to say, hey, for add, we're going to get whatever the function returns back. That's all we're going to do. So we've got this code. Let's see how we could use it. So in our get team names, instead of doing all the code in green, we're just going to say, hey, return get string values team such that team name. And then for team lead, same thing, team such that team dot lead. All that code in green, get rid of it. It's gone, dusted. We don't need it. So that's pretty cool. All right. So we're pretty happy with ourselves. We've removed some duplicated code, and we get another requirement where we want to know the count of everybody on the team. So, all right, we know this song and dance. So we create a get team count. It's really just getting the member counts for each of the teams, add them to a list and return that. This code looks suspiciously similar to stuff we've done before. So we go, all right, cool. We know what to do here. So we go ahead and write an extension method called get int values using the same getter trick, everything that it did for string values. And this works. But now we've got get string values and get int values. And once again, our pattern matching brain kind of kicks in and goes, huh, man, this code looks really, really similar, doesn't it? In fact, besides some naming, the only differences between these two are the types, right? And we saw this before that if we have multiple implementations where the only difference is the types, that means we can make this generic. So let's do that. So we're going to create a new extension method called map, and we're just going to plop in t-result for everywhere that we had int or string. If you're wondering that's called t-result, it's because in .NET, if you're using generics, the naming conventions, it starts with the T. And I chose t-result because you'll see in a moment. And we're going to call this function map. And it's the exact same code that you've seen like 4 or 5 times now, right? So I'm not going to belabor the point much more. So this works. So now let's do some refactoring. Remember get string values and get int values? Yeah, that's trash. Throw it away. We don't need that code anymore. So gone. Get team names, get team leads, and get team counts are all just going to use map. And that'll work, and this will work just fine. It type checks, everything's happy. So that's pretty cool. The question I've got for the group though is there any reason why map should only work with delivery teams? And the answer to that question is no, not really. In fact, if you looked at what we had for map, we just replaced delivery team with T source, and now you end up with this code. And notice how I didn't even have to change the logic, right? The guts of the method were exactly the same. I just had to replace delivery team with the new generic. And once we do that, it kind of just works, which is pretty cool. And I want to call this out. So the version of map we have is almost line for line the exact same implementation that Microsoft has for select on their GitHub. Now, you'll see that their method's called toList, and the reason why is that when you call select, right, that's really giving you back an IEnumerable. So depending on whether you do a toList or a toArray or a to whatever, it does a slightly different thing. So I chose the list one for simplicity, but the code looks almost exactly the same, right? And it kind of has to. There's not really many other ways you could write the code such that it fits all the design properties, right? So we just wrote map. Now, the one tweak we still got to make is that we got to make this work for IEnumerables. Right now, it's hard-coded to list. So let's fix that. So when we go to IEnumerable, instead of listening to lists, we listen to IEnumerables. So that's why this comes in. And then instead of having to have that whole list and we're holding on the list, we can actually just use the yield return keyword. And this will automatically make it lazy and make it an IEnumerable for us. So that's kind of cool. We just wrote map and we wrote it almost from scratch, right? Like we didn't use LINQ or anything to make it work, just using the built-in stuff to .NET. So that's kind of neat. At the end of the day, whether you were able to follow the code or not, hopefully you were able to, but if you weren't, the big thing to remember about map is that it allows you to take a collection of one type and convert it to a collection of another type. As long as you understand that for map, you're in a good spot. Now, before I go into where, I do want to take a moment and see if there's any questions in the chat or if there's any questions in the room. All right, I'm not seeing any or hearing any, so I'm going to go ahead and keep us moving, and let's talk about where. And we're going to call this keep, actually. So .NET, this is the one instance where I think Microsoft gave it a great name. Most languages call what we're about to talk about filter, but the problem is filter is not very clear. Does it keep things in, or does it throw things out? Where, I think, is a great name. It's very clear, like where this thing's true. We're going to call ours keep because it kind of gives it that same nomenclature, right? Like, hey, we're going to keep these things. And so what this does is that where or filter or keep, it gives you a subset of a collection based on some predicate, right? Some true false Boolean value. And this method has a lot of cool properties that we get for free. So the first property we get is that whatever you get back from where, it either has somewhere between 0 items and the original length of items. So if I call where on a list of 10 items, I can't get back 12. That can't happen. It can't create stuff out of nothing, right? It can't give you back items that weren't in the original list. For example, if I had a list of numbers 1 through 10 and I wanted all the even numbers, I can't get 22 out of the list. I can't get back 42 because they weren't in the original list. That's a pretty darn good guarantee. It also maintains the order, right? So if I had a list of numbers 1 through 10 and I want all the even numbers, it's going to give me 2, 4, 6, 8, 10, not, well, here's the 8, here's the 6, here's a 2, here's a 10, here's a 4. Now it's going to maintain the order. And very much like all the other ones, this also doesn't return back null either. So it's kind of nice in that regard. Let's write our own version. So here's our delivery team record again. And we are trying to figure out, do we have any teams that have that are too big, right? For those of you who've been in leadership or maybe around for a bit, you may be familiar with the concept called the two pizza rule, right? You can't have a team that's so big that 2 large pizzas couldn't feed them. So we were going to say 17 members, and we go, cool, we're going to write some code that looks like this. Now, I've short-circuited some of our deriving because we've already seen static methods, we've already seen static classes, so we skipped over that, and we already know about the IEnumerable thing. So we have a function, extension method, called getToBigTeams, and it iterates through teams, and if any of them are greater than 7 for the member count, we yield return the team. Excellent. This works, no problem. But we have another requirement. This time we're trying to see, like, which teams does Dana lead? Because if you're leading a team, that's pretty good, but if you're leading multiple teams, that can get really stressful. And we want to make sure that, Dana's not leading too many teams because we don't want her to burn out, right? So we write the following code, right? We say get teams led by Dana. We do a for each loop and we say if team.teamLead equals Dana. If so, we return that team. This works, solves the problem, everybody's happy. But we take a look at our extension methods again, and we go, goodness, this code looks real similar to each other, doesn't it? Besides some variable naming, i.e. the method names, there's really only one difference between them, right? It's that if check. So let's use the same trick that we used before from map, and let's introduce a func that can do this work for us. So we create a new extension method called getTeamsBy, and it's going to take this predicate. Right now, something you may not be familiar with is that there is an actual predicate type in .NET, but almost no one uses it. Very few people even know it exists. So instead, we're going to say it's a function that says you give me a delivery team, I'm going to return you back a Boolean. And then inside our if check, we're going to say, hey, if this predicate returns true, sweet, return the team. Now that that's working, we can refactor our code a little bit. Right? So here's that function from before, getToBigTeams. Yeah, we just say, hey, get teams by teams such that member count's greater than 7, code in green, get rid of it, don't need it anymore. And then for teams led by Dana, very similar, right? We're going to say, hey, teams such that lead is equal to Dana, return those, code in green, get rid of it, we don't need it. So here is what our get teams by is looking like But take a look inside the guts of this method, right? Starting with that for each loop down. Did we ever see the delivery team type even mentioned? Is it even being used? No, right? The only places that delivery team is ever used is in the extension method signature. It's where it's returning, it's what it's extending off of, and it's the func. But that means if we're never using the type internally, that means it could have been any type, which means we can actually make this generic. So here's what it would look like. We just replaced delivery team with that T source trick from before, and we now call this method keep, and that'll do it. So much so, in fact, that if we look at the Microsoft implementation, it looks like this. Once again, it's called to list for like some of the performance things that Microsoft's doing, but the actual guts of what's happening, it's the same. And it kind of has to be, because here's the pop quiz for the class, for everybody on the call. How many ways could we have implemented keep such that it fit all the design restrictions that we had? And I kind of alluded to this a little bit earlier. Two ways. Either the predicate is true and we return it, or the predicate is false and we return it, right? So is the issue with using the word filter, right? Because I kind of hinted at like filter's not great because are you keeping it or are you throwing it out? So yeah, there's not too many ways you could have implemented keep or where such that it fits all the criteria. So pretty cool. All right. So even if you weren't able to keep up with everything we did in the code, the big thing to remember about keep or where or filter is that it allows us to only get items out of collection that match some criteria that we care about. That's really the key thing here. Now, I'm going to pause and do another check and run on the room in the audience about how we're feeling so far about what we've seen before we go into the last one of aggregate. All right. I'm not seeing anything in the chat, so we will keep rolling forward. Thanks, Ari, for helping me out there. So the big thing about aggregate is that almost every other language calls it reduce. Some languages call it fold. I'm not going to get into semantics about what's the difference between a reduce and a fold. The big thing to know is that you're going from many things, like this basket of eggs currently worth $200 in today's economy, to a tasty frittata. For those of you who did not have dinner tonight, bummer. But that's really what we're doing. We take a list of many things and we're reducing it down to a single thing. So before I go over the properties, I kind of want to show you what aggregate looks like because I find this method to be confusing for some engineers. So let's say that we had the problem that we wanted to sum up the numbers 1 through 10. Well, for aggregate to work, you typically need two things. You need some initial value. And a good way to think about the initial value is what would you get if the list was empty? So if we were summing up a list of numbers and the list was empty, your total would be 0, right? Cool, that's the initial value. And then aggregate needs some function, typically called the reducer, that says, hey, how do I take that initial value and an item from the list and smash them together? How do we do that? And so in our case, we say, all right, well, if you give me what my initial value was, in this case called the accumulator, and you give me an item off the list, I'm just going to add them together. So that's kind of how aggregate works here from a code's perspective. So let's take a look at how we can end up running into this in our production code. So let's say we've got the requirement that we want to figure out how many team members do we have in our department. So we go, all right, cool. I've seen this movie before. I'm going to write an extension method called total number of members. We set total equals 0. And this is just a bog standard running total code, right? Nothing crazy here. This works, solves the problem. We then get another requirement where we want to get all the team names and we want them formatted in a very particular way. So we go, all right, cool. We write another extension method, except this time we are using a string builder or string builder because we don't do string concat, not in this house, right? We know about performance. So we go, all right, we're going to do up a string builder. We're going to append the line teams in the company. And then for each team in the list, we add its team name to the string builder and return back the string builder. And this code works, no problem. But here comes the rub. here's what our two extension methods look like, and they don't look anything the same, right? They're working with completely different types, first and foremost, right? One's dealing with strings, string builders, the other one doing a total. Yeah, we can maybe make something generic, right, with the member count, like integer versus string, but there's not a really simple like plug and play that we could have done, right? But these two methods are following a pattern. They both have an initial value, and they both have a way of combining that initial value with an item from the list. If you ever see this pattern in your code base, you've actually got an aggregate running around 100%. Let me show you how we can make this work. So here is our version of reduce, and there's a lot going on here, so we're going to take it a little bit slower. So the first thing that we have to genericize is the return type, right? Because in one of the methods, it's a string builder. The other one, it's a number, right? So by definition, it has to be genericized. So the cool thing is, though, the minute we genericize that, the rest of this code kind of starts writing itself, because we now know that, well, if our result is of that value, then then our initial value has to be the same type. So it also has to be a T result. And because those things are T result, we know our reducer function also has to be something that says, given a T result and a delivery team, I'm going to give you back a new T result. Has to. There's no other way for this thing to type check. And the minute we do that, we end up with the code here where we've got bar result equals initial value. For each of the teams, we call the reducer function and return whatever our result is. That's pretty cool. So let's see what this will look like in action. So here's our total number of members code. We're going to set the initial value to 0. Our reducer in this case is some func that says, if you give me an integer and an item, I'm going to return you the integer plus the member count. And then we call reduce with those two arguments. For the formatted team names, our initial value is that string builder, right? String builder.append line teams in the company. And then our reducer function says, hey, if you give me a string builder and a delivery team, I'm going to say string builder.append line item.name. And we're really lucky that string builder follows a fluent interface, which means that when you call append line, it returns back a string builder. So we don't have to do anything weird there to make that work. But once we've got the initial value in the reducer function, we can call it, right? Teams.reduce initial value in reducer. And that works. No problem. Same question as before, right? Here's our reduce, but right now it can only work on things called delivery team. But if you look inside the guts of reduce, there's no reference to delivery team, that type at all. It's only in the method signatures. So which means if the type's only in the method signatures, we can genericize that too, which we do here. We just switch out delivery team for T source and everything else would work. Type checks, hunky dory. Pretty cool. So here's our implementation on the left. Here's Microsoft's implementation on the right. Now, they got fancy on us and put some error handling checks on making sure that you're not trying to call reduces on null lists or with a null reducer function. So if you ignore the error handling and you take a look at everything from that T accumulate down, it's the same code. And it has to be the same code. There's no other way we could have written this such that it does what reduce has to do, and it follows all the type signatures. And that's kind of one thing I find really neat about some of these functional programming concepts, that once you understand the types, you end up finding out like, yeah, there's only one way this could have ever worked. Can't work any other way. And if it can only ever work one way, that means you don't run into as many bugs, right? So that's kind of nice. So, oh, and I even had that. So the big thing to remember with reduce is that you're going to transform a collection down to a single value. That's what it does, right? But here's the question. We've done some stuff with reduce, and that's all well and good. But what if I told you that everything that we've written in LINQ, we can actually convert to using reductions instead? And you might be thinking, what? No way, we can't be doing that. But we will. So here's how we're going to do it. In order to use reduce, right, there's two things we got to be able to do. Find its initial value, and then we've got to figure out some way to combine the initial value with some element from the list. If we can figure out those two things, we can convert to using a reduce. Now, let me also preface everything with the following. Do not do this in your production code, This is merely a fun thought exercise. But I promise you, if you do this in your production code, your fellow engineer will ban your PR and potentially kick you off your team. So do not do this. But still a fun exercise to go through. So here's our map from before. So what's the initial value for map, right? And a good way to think about it is what happens if you call map on an empty list? What do you get back? Has to be an empty list, right? So since we're dealing with IEnumerables, we're going to cheat and use the enumerable.empty method. But that's our initial value, which means if we try to write map via reduce, all this code would essentially be auto-generated. It has to be. Because we're saying that our return is source.reduce, here's our initial value, right? An empty enumerable. And we know we're going to be passing in the reducer function, right? Well, that reducer function has to have the following signature. It has to be something that takes in an IEnumerable of T results and a T source item. Can't be anything else. So now we got to figure out a way to convert that T source of item. We got to go from T source to T result. We need something to help us do that conversion. And once we've done that conversion, we need to add that result to the accumulator. If we do those two steps, we're golden. This solves it. So anyone want to take a guess what we have access to here in this code that allows us to convert something from a T source into a T result? It's our selector. It's a function that says, hey, if you give me a T source, I'll use a T result. That kind of makes sense, right? Because that's kind of the brains of what map's doing. So since we have selector, let's use it. So we say, cool, T result, that converted item, we're going to use the selector func. And once we've done that, we can say, hey, accumulator, use dot append. You can write your own version of append. It's not bad. I just didn't want to like clog up the presentation with that. So append is a built-in method on the IEnumerable type. But that's it. You just rewrote map as a reduce. Should you be doing this in production code? Please don't, but you can do it. It'll work. Let's do the other one, keep. So same question as before, right? We got to find its initial value and we got to figure out the reducer function. So the initial value is what should happen if we've got an empty source, right? If the list of items we're working on is empty, what should we return? Surprising no one should be the empty enumerable. So that's our initial value, which means if we go write keep via reduce, and we know our return is going to be that source.reduce empty enumerable in the reducer function, we now know the reducer function has to have that signature. It can't be anything else. Otherwise, the code won't compile. So here's what we got to do inside of it. We got to check to see if the item, does it pass the criteria, right? Is it valid? Should we keep it? And if so, we got to add it to the accumulation, right? The accumulator that we've been building up. And if it doesn't match, cool. Just return the accumulator. We don't need to do any more work. All right. So we got to check to see if the item meets the criteria. What do we have access to in here that would let us know if an item, in our case, T source, was valid, if we should keep it? It's our predicate, right? So we can use it. So we separate if else blocks. We say, all right, cool. If the predicate and the item, if that's true, we're going to do some logic. Otherwise, we're going to do some other logic. So now we've got to add it, and we've already seen how to do that. We can use append. So if the predicate passes, we say, cool, here's your accumulator with that item appended. And if it doesn't, here's your accumulator instead with the item not appended. And this works. Is this a little bit gross? Oh yeah, sure, absolutely. But it works. Type checks does everything. So with that, we've covered a bunch tonight, right? We've covered a whole bunch of concepts and hopefully learned some new stuff. So I'm just going to do a brief recap. So we talked a little bit about what LINQ is, right? We talked about how to set up operations independent of its source of data. That gives you compile time safety when you're writing your code, because if something's going to break, I'd much rather catch it at compile time than at runtime. Right, we did a little bit of a dive on some fundamental concepts in C# and .NET specifically, funcs, generics, and extension methods. We talked about what these concepts were and how they kind of interplayed with each other and how you needed all three in order for LINQ to work. And then finally, we actually wrote our own versions of map, keep, and reduce, right? And in some cases, we actually re-implemented them in via reduce. So let's say that you watch through this entire presentation and you're like, oh my goodness, I feel dumb because I was only able to pick up like half of it or 3/4 of it. That's okay. The big things to remember here is LINQ's not magic, right? It's just a composition of these things, right? It's just function generics and extension methods glued together that allows us to kind of make these bigger applications. That's it. So with that being said, thank you all so much for your time this evening. I really appreciate it. I'll also be around here for a little bit to help answer any questions that are still up. Let's say you have questions after the talk, right? Or you've got a very specific case you want to get into the weeds over with. You're always more than welcome to drop me a line at cameron@softwarementor.com. You can find the slides once again at that QR code. So thank you all so much for your time this evening. I appreciate it.
Hey, thanks for that, Cameron. Yeah, let's all clap. Yay.
Hooray.
Hooray. Let's see how many people we have online. Oh, Mazar, you were able to join. That's good. Okay. Good, good, good,
Yes,
good,
thank you
good.
so much.
Well, I saw your message like 10 minutes in. I'm like, ah, crap. And then I was able to finally paste it in. Like Meetup wouldn't let me paste the thing in until I like quit Meetup, and then I don't know. It's crappy software like that. Yeah, that
Well,
makes me know that there's always opportunity out there.
I like the fact that you absolutely made sure to get that recorded. Like, I
Yeah,
want that for posterity. I want that in the transcript.
it's an
it's
awesome presentation.
it's true though, isn't it? Like like every time you see crappy software, you realize that AI has not replaced any of us yet, or that if it has, our salary will double next year or something.
Oh
when
my
they
goodness.
finally realize it. Um,
So I've got one last thing.
yeah.
For those who were able to catch the presentation live, let's say that you felt very encouraged or like, hey, I want to know more, but I need to go deeper. I'm actually launching a Udemy course, summer 2025. If you are interested in knowing when this goes live, feel free to scan the QR code. What this will do is it will kind of pre-populate an email that you can send to me to let me know, like, hey, you're interested. If you send me that email, I will absolutely make sure that you get a discount code, and I'll let you know when this goes live. So the course in general is we're actually end up building the game of blackjack, kind of like a simple console app, using functional programming concepts. So like it's intended for those who've never done functional programming at all. Um, I launched a Udemy course last year that did pretty well. That was more on the TypeScript side. So for this one, I'm kind of toying around whether to do it TypeScript and or have a version in C Sharp. Um, but if it's something you're interested in, scan the QR code and I'll let you know when it goes live.
Awesome.
Sorry, or I had to do a little bit of shameless promotion there, just a little bit.
You should do that shamelessly. You should do that. Absolutely. You got anything else? Talk about books. It's all good.
Oh no, man, I've not had the heart to do any book writing, but yeah. Otherwise, I love geeking out about this type of stuff. So definitely always down to chat more.
Awesome. Well, thanks so much. It was such a great presentation. Did anyone have any questions? No?
You all are definitely smarter engineers than I am because
You were?
it it took me a while to learn this, but your fun aside, though, if you're curious about where this talk idea came from, it was actually back when I was working at a previous company, and I was working with an engineer who kept struggling with LINQ. Like they were just really struggling on getting like select and like where and aggregate. And my way of learning how stuff works is I like to build my own version of it. So I actually challenged them, like,
Yep.
we can absolutely write this in like an hour. And
Yeah.
then after we wrote like the 3 or 4 methods within an hour, they were like, Cameron, you should absolutely like do a talk about this. Here we are.
Oh, yeah. I actually think this is a great opportunity to explain to junior and possibly even intermediate developers architectural patterns and talking about how, this is the enumerable pattern.
Mm-hmm.
Yeah, I just explaining those things like these are patterns that you'll read about in the Gang of Four, and you're like, oh my gosh, LINQ is entirely about the you know enumeration or the enumerator pattern.
Yep.
Yeah, just yeah. Anyone know the enumerator pattern? Yeah,
Oh,
yeah, okay, good.
would it be called iterator by chance?
Iterator.
Yeah.
That's yeah.
That
Shut up.
enumerable
I'm
that
kidding.
that's your Microsoft background rubbing off
Yeah,
on man. That's
iterator.
exactly what
Yeah.
that is.
Well, you know what? I'm one of the guys who likes select. So, yeah.
Yeah,
But
no worries.
I don't usually see. Well, I mean, I know that it's called map, but do you remember like Java? Didn't they call that project? You projected it. It
Oh,
wasn't mapping.
so the thing is with Java, they didn't get LINQ until
Oh, it was forever later. Yeah.
yeah. So to put some, I'm gonna date myself a little bit. I started my software engineering career in 2011. LINQ had
Oh,
just came out then.
wow.
Java, I
For
think,
Java. Yeah.
came out like 3 years ago, maybe four. So there's
Wow.
like almost a decade difference in between the two.
Yeah, it's the iterator pattern. You're right. Gosh. Anyway, Mazar has a question.
Yeah, what you got?
Yeah, I was gonna say, thanks for you know, especially the last slide. It was pretty informative because saying link is not magic because I'm still learning Swift, but even so, other languages, link's always been a huge thing because I'm a C# developer, and it's link is very common, right? And that's one of the things is in Swift, there isn't anything strictly named link, but then you break it down this way and you're like, wow. Because I mean, I already read before that there's map and reduce and you can use those components to do it, but I didn't know exactly if that was just how that actually how it actually was compared to link, but that's just what link is. It's just, basically the composition of those. So it's pretty cool.
Yeah, awesome. Thank you. I appreciate that. And I'm glad it's helping you like connect some dots too.
Yeah, yeah. Because I mean, the more you can relate other languages to each other, the easier it is to program and get stuff done. So yeah, cool.
Bingo.
Yeah.
Did this start at? Let's see. Did it start at 6?
It's about 6:40, 6:45.
Okay.
Yeah.
So
And
then
we
you have the
record the whole
PowerPoint.
thing, Mazar. So if
Oh, okay, perfect. Okay, thanks.
yeah. So you'll any part that you missed, you'll be able to watch it. I have it on my to-do list to post it tomorrow, but we'll see how the day goes.
So Cameron, you mentioned that you
Yeah.
don't use it in production, that the reconstituted versions.
Oh yeah, please don't.
What have you done though, the in production, any of this where you've actually utilized any of this stuff?
Oh, I mean, I use LINQ all the time.
Yeah.
No,
Right,
besides
like
Link. I mean, just you're strictly using Link, the Microsoft Link. You obviously said all this stuff you don't want to do in production, but are there any other tricks that you've kind of used to augment Link in
hmm,
production?
I think that's the first time I've ever been asked that question. I'm gonna sit and chew on that for a minute.
I know I use parallel link. I use Plink.
Yeah, that's one that comes up a lot. So the biggest trick to know, and we're gonna dip your toes a little bit more into functional programming land. So there's a concept. So we all know what functions are, right? Like you give some input, get some output back. When you're defining your functions, there's really two flavors though. There's something called pure functions and then impure functions. Pure functions are functions that work only on the data that's passed in. It doesn't go out to like file systems, network calls, type clock, math dot or system.random, doesn't talk to any of that stuff. What I've found is if you get into the habit of using pure functions with your LINQ, you'll actually start grokking more common functional programming paradigms because that's kind of how they work. So what you'll find is if you get more comfortable with LINQ, you'll actually start becoming a lot more comfortable with other functional programming languages in general. So you'll find that like crossover bleed over pretty common. So if you're like, hey, what's the next thing I might want to start looking into? That would be the concept is knowing what a pure function is versus an impure function, and then how can I make an impure function into a pure one? that would be kind of like the next steps down that way. But when I get asked like, "Hey, Cameron, I'm really interested in functional programming. What do I do first?" I say, stop writing loops as much as you can and just go to the LINQ. And that's a really good stepping stone.
Sounds good.
Oh, when it comes to sorting, LINQ is not necessarily very good at that.
With the
So
order by stuff.
yeah, well, order by and then summing values and working with large data sets. So one of our members actually wrote something called HP.NET, which is high-performance.net. I think anyone here that's been here for a while has probably seen his presentation at least once. And it's very cool because it's like orders of magnitude faster than LINQ when it comes to sorting. And it's still all written in C#. So it's I think he open sourced it. Yeah, it's an open source solution. It's a NuGet package. But
cool.
if you're doing a lot of work where you're aggregating large values or sorting, then check out hp.net. And it goes, I mean, you can still use LINQ, but just because LINQ is there does not mean that it's the fastest solution. So just keep that in mind. And you can, since you were asking, Nazar, depending on how you're using LINQ, you could use it incorrectly. So you want to be very careful there.
Yeah.
Like multiple enumerations, enumerating when you shouldn't, like too early. And yeah, thoughtful about the order that you're going to perform your operations. And there's nothing wrong with passing, well, maybe when it comes to pure versus impure functions, right? But passing a iQueryable or what have you across multiple functions that kind of doctor up your query, but only running it once.
Yeah.
And that's especially true when it comes to working with any sort of external data source, SQL or otherwise. Just keep that in mind.
My hot take is that I really wish they hadn't given us iQueryable. Because here's why. All right, cool. You didn't realize you were going to get me on soapbox, but here we go.
Okay, you're recorded.
Yeah. So I like iQueryable in the sense of it can convert your LINQ into query statements, right? Like it'll actually translate the SQL. That's great. The problem goes though, and they still have not fixed this, is let's say you've got some logic inside your LINQ that you want to extract out to a public method because maybe you want to write unit tests on it, right? You want to test your business rules. The minute you extract that function out, you no longer get a compile time error. You'll actually get a runtime error because now what's happening is .NET is sending a function reference over the wire, and of course SQL Server doesn't know how to process that, so it chokes.
Yeah.
I really, really wish that the like the .NET compiler would warn you at a minimum to say, "Hey, that legit won't work." Like,
have you proposed it?
I've not proposed it because it's not the hill I'm wanting to die on stuff I want them to implement.
Yeah, you could be like everybody else that posts a comment on GitHub.
Yeah, it's the one that trips up engineers all the time. And the way to solve that problem is non-trivial. Like you have to end up building like an expression builder type thing so that it can then figure out how to do it. And it's a pain in the butt. So if you're looking for like my, hey Cameron, 10-minute hot take, go for it. There you go.
What was the question?
We're talking about SQL translation for client versus server side processing.
I think he's saying that when you put an inline function in something that ends up using LINQ to SQL, it tries it can't convert that inline function. It's going to say, I don't know how to do what you just asked me to do on SQL Server, which is normal. That's especially true with like string manipulation. Yeah, you got to be very careful. But LINQ to SQL though is its own weird beast, right? It's like the fact that it works is very cool, but it's also a bit of a magic box.
So I'll give you 1 second here.
I mean, that's
So
never
for-
like a compile time error, right? I mean, LINQ
Yeah, no, it type checks and all that
but
fine.
if a LINQ to SQL is coming back saying, I don't know how to translate that.
So for the person who asked that question, this code is a good example. So let's pretend that Teams was coming from like Entity Framework, so it's an iQueryable. If I had done, let me get the cursor back. If I had done this code, it'll work just fine. No problem. It would compile, it'd run, things are great. The minute I make this refactor, it breaks because it doesn't know how to convert the function called isTeam2Large into SQL. It doesn't know how to do it. So
Right.
what you have to do instead is you have to do, I'm pretty sure it's called an expression builder, but you essentially got to define isTeam2Large into an expression that will essentially help it convert and figure out like, oh, we're just taking this property off an entity and comparing it to a number. But if you are an associate or mid-level engineer, kind of like as Ori was kind of hinting at, this is a non-trivial thing because this is a refactor that like ReSharper would offer up. Right. And it's not clear why, it's not obvious why it would break. And so that's kind of my biggest problem with iQueryable is that because it inherits off IEnumerable, yes, you get all of LINQ, comma, however, you also get this other stuff that can break on you if you don't know what you're doing. And if it was going to break, once again, I kind of want to break at compile time, not runtime. That's really the problem.
Yeah. Well, I mean, I guess it makes sense. And if you think about it, LINQ to SQL doesn't compile the SQL at compile time, right? It compiles it during runtime.
Correct.
So until it actually goes and receives the LINQ query, it doesn't know how it's going to handle it. And I mean, the .NET compiler, it makes sense that it's like, well, I mean, it's legitimate code. I mean, I don't know if the runtime is going to be able to handle this or not, but that's not my job to judge whether it'll work. Just like any external service, right? So, I mean, it's in process, but it's an in process service, right? It's not something that the compiler could actually check. It could, now it would be cool if it would give you a warning, like, hey, somewhere near this, it looks like you're going to pass this to a context, some DB context. And hey, I see you've got something that has a function as a parameter rather than like a named function as a parameter rather than another LINQ expression, whatever. And mark it as a warning. But then now you're modifying the .NET compiler to give entity framework special treatment. So it's like beyond syntactic sugar. So I could see them arguing, well, yeah, but then we'd have to do it for insert all these other frameworks, that are runtime things, like anything that might be handling an exception and sending it off to something that logs something. And well, I should know that thing doesn't support Unicode. Yeah. And, it'll blow up on me. But I don't know. I mean, I can see Microsoft's argument either way, right? But
something. Language warning. Doesn't know how to resolve it. I think it's doing like a mock translation and compile time.
okay. So it knows what driver you're using. I guess it would know what type you're using. Yeah.
Trigger.
So maybe there's and I don't know compilers that well, so maybe there's a compiler extension that's added. So during compile time, maybe they do some code analysis.
Yeah.
Well, there's something to check out because maybe it's something you can enable on maybe there's a flag with EF that you can check.
And I think it's tied in with, they're very good at enforcing or predicting which parts of the chain are client side logic versus server side logic.
You hear what he's saying? Okay. Oh, you're welcome, Prasad. Yeah, that would be. If you could post a link to that, that might be helpful, like in the comments. Yeah. And then camera will know, and then yeah. See? One team.
It's the Postgres provider's way ahead of us.
Yeah, I haven't. What am I using right now? I'm using SQLite for one, and then I'm using MySQL and Azure SQL. Oh, oh wow! I didn't plug in this whole time. That's nice that that thing actually survived.
Literally 30 seconds before it shuts down. So.
Oh, mine will be like it's really low and then shuts it down. So, I'll plug it in so we don't lose anything. But Cameron, it's been great. You got to present again soon, yeah.
Yeah, no, absolutely. So Ori, we can chat because I think I'm going to be in your all's neck of the woods in the not too distant future.
Okay, that sounds great.
Yeah, so I felt really dumb about this because I was in Ohio for Star Trek last week, and I looked on the calendar and I realized oh, this is only like a couple hours further west.
You're welcome, Azar. Oh yeah.
Well, so
Where
I'm
are
actually
you gonna be?
well, I was so in August I'm actually going to be in Cincinnati.
Oh yeah, that's 2 hours away. Yeah.
Correct. And so that's a doable thing. And I'm trying to get in for Momentum, and that's in October. So that may be another instance where hey, this might make sense. So we can chat offline about what we can do to, because don't get me wrong, virtual works, but if I'm only 2 hours down the road, I'm only 2 hours down the road. We can absolutely make something
Oh
work.
yeah. Well, and send
And,
me some topics that you'd want to present on, and then we just get it scheduled in, whether it's virtual or not, just so I get it on the calendar.
yeah, sure. Absolutely.
Do we have any other questions? Okay, I'm gonna stop recording and then I'm gonna tell you a story.
Oh man, now it's really coming out.